Hey race fans, it's Mrs. Fitch. So today we're going to continue our conversation about sequences, and we're going to add this little piece on there called recursive sequences, but ultimately we're going to look at sequences and then we're going to still work on coming up with those equations, which we started yesterday. So hopefully by the end of the lesson today and with yesterday's, we'll be able to write sequences and their equation, and we can know the difference between recursive and explicit. Okay, so let's start off with a sequence. So let's say we have -8, -2, 4, 10. I'm going to throw some dots there on the end. So we know it's a sequence because it's an array of numbers, and we know that our sequence is going to continue forever because we have our little dot, dot, dot at the end. So when we look at our sequence, we want to see if we can determine if this is arithmetic, which is where we're adding numbers to each, or if it's geometric, if we go from one term to the next by multiplying. So how do we get from -8 to -2? We could technically multiply by 4, but if we multiplied by 4, I'm not going to go from -2 to 4. So I can get from -8 to 2 by adding 6, -2 to 4 by adding 6, 4 to 10 by adding 6. So this is telling me that it's arithmetic because I'm adding, and then my common difference, or we could even refer to this as slope, is how do I get from one term to the next? It's a difference of 6. Right? So our goal, ultimately on all of, in Algebra 2 is to be able to do that multiple representation. So we want to be able to do like a table, a graph, and an equation. And today we're going to skip the graph part of it, and we're really going to focus on tables and equations. So I can take my sequence and I can turn it into a table where I use n and then t of n, so it's just our notation. This tells us the term number, and this tells us the value in the sequence. So when it comes to terms, currently we are showing 4 terms. First term, second term, third term, fourth term. So my first term is -8. My second term is -2. My third term is 4. My fourth term is 10. Right? So my question is could we actually keep this going? So 5, 6, 7, 8, 9, and find out the 10th term. So granted, we could go through and we could keep adding 6 until we get to the 10th term. Or we could try and come up with an equation and see if that might be a little bit quicker. So in our discussion yesterday, we sat there and said if we took a sequence and we graphed a sequence, it's discrete because it's only those individual terms, so we can't connect the points and make it into a function. But it does look like a line. An equation of a line would be like y equals mx plus b. So the only difference between the sequence and the line was on a sequence, it's discrete, so we're not connecting the points, where if it was a function, we would be connecting the points. Same thing applies when it comes to our x and our y. X is our input, y is our output. So in our table, n is our x, right? That is our input. After we put in 1, we end up getting -8 for our term. So our y and our t of n, those two are exactly the same. M is our slope, and if we think of a line, the slope is how do you get from one point to the next. In a sequence, how did we get from one value to the next? We had that common difference of 6, so we added 6. So our slope and our common difference are the same thing. B is the y-intercept, which is where it crosses the y-axis, and we always cross the y-axis when our x value is 0. So for our sequence, our intercept would be when our, instead of x, it would be when our n value is 0. So we could figure out our 0 value if we would like. So we added 6, we add 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 6. So if we wanted to go the other way, we would do just the opposite, and we would actually subtract 6. So -8 minus 6, and I'm just going to write it on here. So to get this term, it would be -8 minus 6, which is going to give us -14. So we can write the equation of our line, or the equation for our sequence. Instead of y, we write t of n, and that equals m, which was our common difference, which is 6. Instead of x, it's going to be n minus 14. So now if we wanted to figure out, so the question was, what's the 10th term? So if we want to figure out our 10th term, t of 10 equals 6 times 10 minus 14. So t of 10 is going to be 60 minus 14. So t of 10 is going to equal 46. So our 10th term value is 46. So I want to talk about this is called the explicit formula. So this is actually called the explicit formula. So let's just talk about our two little forms. So if we want to talk about the explicit equation, when we talk about y equals mx plus b, how that's for a line, when we're doing it for sequences, we kind of just change the variables that we're using. So our y, we said, was t of n equals, for our slope is that common difference. So instead of m, we write it as a c. Our x was our inputs, and our inputs are actually n's when it comes to sequences. And b, which is our y-intercept, which is when we cross the y-axis, which is where your x value is 0. So for us in our sequence, it's our 0 term. And yesterday we learned that if we write the letter A and those little subscripts underneath, that tells us what term we're looking at. So this is telling us we're looking at that we're looking at that 0 term in our sequence. So let's label these. So C was our common difference. N is the term number. And A of 0 is the 0. I'm just going to put a line through there so it looks like a 0, not an O. The 0 term. And if we go back to the equation that we just came up with, what was it? T of n equals 6n minus 14, right? We found out that our common difference was 6. N is the term, so depending on what term we're looking for. And negative 14 was our 0 term, which was negative 14 that we came up with. The other equation that we talk about is called the recursive equation. And in order to use the recursive equation, you always have to know the term before. So if I wanted to figure out the, whoops, I did not mean to do that. If I want to figure out the third term, if I want to figure out that this was 4, it's telling me that I had to know the term before it in order to find out. So we don't use recursive formulas a whole lot because a lot of times we like to find terms that are way down in our sequence or somewhere crazy in our sequence and not necessarily right where we can like see it. But we're going to talk about it real quick. So when it comes to a recursive equation, you always start off with whatever your first term is. Whoop, I need my pen. So you're always going to start off with your first term. When we wrote our first term, we came up with, from our table, from either looking at our table, we knew that it was -8, or by looking at our actual sequence, we knew that it was -8. So our t of 1 is -8. And then we need to find the next term. So technically our next term would be the second term, but we write that as n plus 1. N is the number of terms, and we're trying to find the next one, so it'd be 1. So for us, we would take our previous term, which is our t of n, right? Because this is telling us we're up 1, so we had to go back. So to go back, it gets rid of the 1, right? So we just have t of n. And then what did we do to -8 to get to -2? We added 6. And usually we throw little brackets around it to say that that is all together. So that's how when it comes to writing our recursive equations. Alright, so you guys got a few problems to work on today. So enjoy the rest of your day, and I'll see you guys tomorrow. Talk to you later. Bye.